Okay, in this video we're going to talk about the slant asymptotes of rational functions. So first we got to know when that'll happen. So a rational function, remember that's a polynomial divided by a polynomial. So a rational function will have a slant asymptote if the degree of the numerator is 1 more. So it's got to be exactly 1 more than the degree of the denominator. So as long as that's true, you're going to get a slant asymptote. So for example, we might have y equals x squared plus 3x plus 4 over x minus 3. Degree of the numerator is 2. The degree of the denominator is 1, so that will have a slant asymptote. You might see something like y equals 3x to the 5th plus 5 plus 4x minus 3 over x to the 12th minus 4. Degree of the numerator, 5. Degree of the denominator, 12, so no slant asymptote. And then you might see weird things like this, where you got to figure out the degrees. And if that's the case, so we have, I'm going to put in a 1 there, and we get, so in the numerator, you have a 2, a 1, and a 3. Those are your powers. So your degree there is going to be 6. And in the denominator, we have, I'm going to put in the 1s. You have a degree of a 6. And since the degree of the numerator equals the degree of the denominator, in this case, we are not going to have a slant asymptote, but you have to figure it out. So let's take a look at some examples. What did I actually? Yeah, I accidentally said there was one. There's not a slant asymptote there. Okay, so here's an example. Y equals 2x squared plus 3x minus 4 all over x plus 3. So the degree of the numerator is 2, the degree of the denominator is 1, so this definitely has a slant asymptote. Okay, so what we're going to do now to figure out the slant asymptote is you do long division. So I'm going to do long division here. There's actually a better way to do this particular problem, which would be synthetic division, but right now I'm going to do the long division. So we set it up. So the numerator goes inside the, I always call it the house. It goes inside the house, and then the x plus 3 goes outside the house. And the first order of business here is to figure out what I need to multiply x plus 3 by so that it cancels this 2x squared. So what do I need to multiply x by to get 2x squared? I need to multiply it by 2x. So what I do now is I take 2x and I multiply it by x plus 3. So that gives me 2x squared plus 6x. So the reason I'm doing that is I want to constantly, I call it killing the term. So I want to kill the 2x squared term. I want to get rid of that x squared. So I'm going to put parentheses, subtract, and then you just subtract down. So 2x squared minus 2x squared is 0, and then 3x minus 6x is negative 3x. You bring the negative 4 down, you repeat the process. So now I got a negative 3x, I have an x, I need to multiply x by negative 3 to kill the negative 3x term. So I'm going to erase that, and then I multiply it out, and I get negative 3 times x is negative 3x, and negative 3 times 3 is negative 9. Parentheses, subtract, that'll give me 5. So I can actually rewrite my original function as 2x minus 3, and then plus this remainder divided by x plus 3. Now, if you think about, look at what we have there. If x gets really, really big, or even only sort of big, so say when x is 100, the 5 over x plus 3 is now 5 over 103, which is really close to 0. As x gets huge, that remainder term stops mattering quite so much. So the slant asymptote is what you're left with. So for this particular function, it has a slant asymptote of 2x minus 3. So in general, the slant asymptote will be what you get. So it's the quotient, and you ignore the remainder. Let's take a look at another one. So we have this, which is kind of ugly. So I'm going to set it up like so. And so I want to kill the 3x cubed term. So I need to multiply by 3x to make that happen. So I'm going to go through and do that. So I get this, put parentheses around it, and subtract. So I like to do this in a really organized way. I got to drop down the 1. So I need to kill the negative 4x squared, so I need to multiply by negative 4. So let's do that. So multiply it out, put parentheses around it, and subtract. Okay, so as soon as the degree of this polynomial we end up with when we do the subtraction is less than the degree of the thing we're dividing by, we're done. So we can rewrite the original, if we want to, as 3x minus 4, and then plus the remainder divided by the divisor, So we have that. And as x gets really, really big, that remainder part doesn't really matter. So the slant asymptote for this function is going to be y equals 3x minus 4. Okay, so that's how you find slant asymptotes. You check the degree of the numerator and denominator. The degree of the numerator needs to be 1 bigger than the denominator. You do division, and you end up using the quotient, and you ignore the remainder. So that's how you get your slant asymptote. Hope you found this helpful, and good luck.